Hello friends, welcome to our YouTube channel. Our today topic is counting mathematical induction and discrete probability. We are discussing today counting theory. In daily lives, many a times one needs to find out the number of all possible outcomes for a series of events. For instance, in how many ways can a panel of judges comprising of 6 men and 4 women be chosen from among 50 men and 38 women? How many different 10-lettered pen numbers can be generated such that 5 letters are capital alphabet, the next 4 are digit, and the last is again a capital number? For solving these problems, mathematical theory of counting are used. Counting mainly encompasses fundamental counting rule, the permutation rule, and the combination rule. The rules of sum and product. The rule of sum and rule of product are decomposed difficult counting problems into simple problems. The rule of sum. See here, if a sequence of tasks T1, T2 up to Tm can be done in W1, W2 up to Wm ways respectively, the condition is that no task can be performed simultaneously, then the number of ways to do one of these tasks is W1 plus W2 up to Wm. If we consider two tasks A and B which are disjoint, see here, this is the example. Next is the rule of product. If a sequence of tasks T1 and the ways are W1 up to Wm, then the task is in this way, like as this is. The example is a boy lives at X and wants to go to school at Z. From his home X, he has to first reach Y and then Y to Z. He may go X to Y by either 3 bus routes or 2 train routes. From there, he can either choose 4 bus routes or 5 train routes to reach Z. How many ways are there to go from X to Z? Now see the solution. From X to Y, he can go in 3 plus 2 is equal to 5 ways. This is the rule of sum. Therefore, he can go Y to Z in 4 plus 5 ways. Total is 9 ways. This is the rule of sum also. Hence, from X to Z, he can go in 5 into 9, that is 45 ways. Rule of product. This was the our counting. Next is permutations. A permutation is an arrangement of some elements in which order matters. In other words, a permutation is an ordered combination of elements. See the example. From a set S is equal to XYZ, he takes 2 at a time. All permutations are XY, YZ, XZ, ZX in this way. Okay. Next is number of permutations. The number of permutations of n different things taken are at a time is denoted by NPR. In this way, where n is equal to 1 dot 2 dot 3 dot up to n. Proof. Let there be n different elements. There are n number of ways to fill up the first place. After filling the first place, number of elements is left. Hence, there are n minus 1 ways to fill up the second place. After filling the first and second place, n2 number of elements is left. Hence, there are ways to fill up the third place. Okay, as you have seen here, the total number of ways to fill up the place. Some important formulas of permutation. If there are n elements of which a1 are like of some kind, a2 are like of another kind, a3, and so on, then the number of permutation of these n objects is like in this way. Okay. Next is number of permutations of n distinct elements taking n elements at a time, npn. In same way, the number of permutations in different categories. Now there are some problems. Problem 1. From a bunch of 6 different cards, how many ways we can permute it? The solution is, as we are taking 6 cards at a time from a desk of 6 cards, the permutation will be P6. Next is problem 2. In how many ways can the letter of words reader be arranged? Solution is, there are 6 letters word, that is 2e 2 times, a is 1 time, d is also 1 time, and r is 2 times in the word reader. The permutation will be on this way. Problem 3. In how ways can the letters of the word orange be arranged so that the consonants occupy only the even positions in the word orange? There are 3 vowels and 3 consonants in the word orange. The number of ways of arranging the consonants among them are in this way. Next is combinations. A combination is selection of some given elements in which other does not matter. The number of all combinations of n things taken are at a time is this. Problem first. Find the number of subsets of the set having 3 elements. The solution is, the cardinality of the set is 6 and we have to choose 3 elements from the set. Here are the ordering does not matter, hence the number of subset will be this way. Problem 2. There are 6 men and 5 women in a room. In how many ways we can choose 3 men and 2 women from the room? The solution is, the number of ways to choose 3 men from 6 men is in this way, and the number of ways to choose 2 women from 5 is 5c2 in this way. Hence the total number of ways is this, and this is equal to 20 into 10 in this way. Okay, now this is the problem third. Next is Pascal identity. Pascal identity, first derived by Blaise Pascal in 17th century, states that the number of ways to choose k elements from n elements is equal to the summation of number of ways to choose k minus 1 elements from n minus 1 elements, and the number of ways to choose elements from n minus 1 elements. The proof is, this is the way, see here. Okay, next is Pigeon-Hall principle. In 1834, German mathematician Peter Gustav, this is the name, Dirichlet, stated a principle which he called the drawer principle. Now it is known as the Pigeon-Hall principle. This principle states that if there are fewer pigeonholes than total number of pigeons and each pigeon is put in a pigeonhole, then there must be at least one pigeonhole with more than one pigeon. If n pigeons are put into m pigeonholes where n is greater than m, there is a hole with more than one pigeon. For example, 10 men are in a room and they are taking part in handshakes. If each person shakes hand at least one and no man shakes the same man's hand more than once, then two men took part in the same number of handshakes. Okay, next is, there must be at least two people in a class of 30 whose names start with the same alphabet. In inclusion exclusion principle, computes the cardinal number of the union of multiple non-disjoint sets. For two sets A and B, the principle states, this is the A union B in this way. Okay, this is the problem and the solution is also given here. You can learn problem 2. The same solution is here. So this is our today class. If you like our video, I request you to share among with your friends, comment for your doubts, and like our video. Thank you very much.